Hey everybody, welcome to another episode of Probably Private. I'm Catherine Jarmal, and today we're going to talk about synthetic data. I'm actually going to be walking you through a notebook that I will definitely link in the description so that you can try generating your own synthetic data and compare a variety of different approaches. So, why do we need synthetic data? Generally, I'm not a huge fan actually of synthetic data. I think we should probably try to use real data if we can, especially if we're working on something that's business critical or that's really important. And there are methods for us to do that with privacy involved. And that's basically what my entire first book is about, Practical Data Privacy. I'll put a link to it. So if you're a data scientist, a machine learning person, or even just somebody curious about those things, definitely check that out as a resource of how can we use real data safely if we're doing things like data science, machine learning, data engineering. However, and in that book, I say lots of mean things about synthetic data for lots of reasons. Well, not lots of mean things, but I say a few mean things because they're grounded in both my opinion and experience. But why am I now doing a video on synthetic data? It's because I did not presume that we would have the types of use cases that we're seeing a lot now with AI LLM workflows, which means you're not using machine learning, you're building, and maybe you're using many, many machine learning systems that connect with a variety of vendors you're using. So typical today's AI workflow, which is we have a business use case, but we're sending the data to a third-party AI vendor. And we may have an agreement with that vendor, we may not, we may be testing different vendors. And for that reason, I think synthetic data actually becomes really useful when we reason about, hey, maybe we shouldn't send our actual business critical data to this random third-party AI endpoint, okay? So we're going to go through, like, this could also be your coding assistant, right? It doesn't have to be that you see it sending, just that it is sending. Okay, so we're going to talk about a few different ways to generate synthetic data. And we're going to talk about the differences in the privacy guarantees that you have for each of them. The number one way I would say fully private data is fully synthetic data. And a lot of people call this dummy data. Yes, because it doesn't contain a bunch of information. Let's take a look at Faker. So I already have Faker on this computer. Okay, I hope this is legible. I made it a little bit bigger. We can do things like get a name. We can get text, right? Text doesn't make any sense. That's fine. Unless, we want to write our own text here synthetically, which is fine too. We could use an LLM to do that. And LLMs we can definitely use to create synthetic data. I have an example of that, especially if we need text data. Just know you might want to choose a few different models to generate the text and just be thoughtful about what you put in the prompt and maybe try out a few and take privacy into account there. So I wouldn't put business critical stuff in the prompt unless it's from a trusted provider you have an agreement with. So I can add providers. So there's a bunch of providers that come built into Faker. Here's one for internet addresses if you need to generate those. You can build your own provider. It's not that hard. I can make random Python iterables, right? I can do things like this. And this is also great for thinking through testing and test data. I think Faker is a really good source of that, and combining Faker with things like property-based testing, which I'll put a link to in the description, is a good way to just in general test that your software is functioning properly. And also a way for you to create some good test data that you can test with whatever AI endpoints you're using. We can even regionalize. So here you see that I have created a German regional Faker. There's a variety of internationalizations. You can look through the documentation, which of course I'll link. And here is names that are very much more German in nature, and also a phone number that is a valid local German phone number. So if you do need that localization, if you do have some business logic that requires, okay, we only take this type of phone number or this type of address or these types of postal codes, those are all things that you can add there. Now you can get fancy with this. So I have an example here from my Data Fuzz repo, which was a project that I don't really develop anymore. But the idea of Data Fuzz was, can you generate data that has errors in it and then catch it as part of your data quality and data engineering efforts? But you can take a look through this for some basic ideas. But some ideas that you can use is you can use libraries like Numpy, Scipy, or you can even use modeling libraries like scikit-learn for machine learning, PyMC3 for Bayesian modeling. And you can develop a little bit more of fake data factories. Like, how might you do this? Numpy and Scipy both have ways for you to sample from a distribution. So you might first say, okay, I'm going to make like a basic Gaussian distribution using NumPy or SciPy, and it's going to have this max, this min, this mean, this median, any other types of distribution-based properties you want to build. Or you can do skewed distributions, you could do gamma, you could do beta. You could do those distributions, and you can use things that you know about your data to make something that looks similar enough but isn't actually using your real data. And then as you do that, you might build more nuanced approaches. So you might try to learn your distribution by using scikit-learn clustering to give yourself an idea. What are the distance and relationships in different ways that we can shape this data? Or you might use PyMC3 to think through Bayesian thinking about sampling and understanding the properties of your distribution. And either of these can inform using NumPy or SciPy, or actually help you build something that you could turn into a generator, right? Because once we have a representation of a distribution, we can usually use those things to then generate from the presumed distribution, or at least test things and say, how likely is this value to be in the distribution or not? And we can make a little loop and say, until we reach 80% likelihood this is in the distribution, we try to pull a different value. So those are ways, depending on your engineering level of effort, but I think ways that you could make use of the things that we have from statistics and machine learning to generate synthetic data that starts to look more similar to your real data, but has definitely not actually your real data in it, right? Especially if you're combining it with like Faker and these things to choose your numeric values, you really are having truly synthetic data. And then we have kind of an area that's probably private. There's a library called Synthetic Data Vault, and let's go through it together. It's all installed here, so don't need to worry about it, but that you'll want to load for yourself. I'm going to download some demo data for them that they have hotel guest data. We can look at the metadata for an idea. And so if you're going to be using SDV with your data, I recommend you really dive into how do they do metadata. They have some flags, PII. Don't really like using PII, but that's what they use. We have like different data types. So Boolean, categorical, numerical. We have date times. And so familiarize yourself with some of the syntax that the library uses. If you're going to be using this for your own data, they also have a how-to on how to connect your own data and provide this type of metadata. And if we look at what they provided, we basically have a fake idea of what maybe a hotel customer pricing system looks like, with customer details, with room types, amenities, check-in, check-out, and rate, and credit card numbers. I don't know why they have fake credit card numbers there, but they do. So what we're using here is a Gaussian or Gaussian copula synthesizer. What does that mean? We can think of this as a way to combine more than one variables, so multivariate, and then cumulative distribution. So how do these variables all interplay with each other to create the full data that we've represented? So here I've fit it to the real data. I've fit it to all the real data. Now, you might be thinking maybe we should sample it, all of these things. I think that there's ways to do that in the documentation, but we fit it to the real data. And it's generally used to describe and model the interdependence or dependence between the random variables. What does that mean? It's gonna, for our thing, it's gonna look at all of these values. It's gonna look at the columns compared to each other, and it's gonna find those correlations, which means it's probably gonna be able to auto-magically, and I say this with quotes because it's just using some basic statistics to say, hey, when room type is basic, the room rate is lower, for example. Stuff we probably already know, but we can do. And so we can look through the synthetic data. So we can sample some synthetic data. This has created 500 rows of synthetic data, and we can start comparing it. Now, one of the really cool things about SDV that you might want to use, even if you don't use it to actually generate the data, is they have these evaluations, right? And here you can pass in real data, synthetic data, and then of course you have to use the metadata, and it can go through and look at something like data validity, the validity of the data and the structure. So validity are the primary keys consistent? Are the continuous values, so let's say numerical values, for example, do they meet the min-max? And are the discrete values, so the categories, correct? And then the structure makes sure that the column names are consistent, which is probably already in a lot of ways ensured by the metadata, but maybe there's ways to pass metadata where you don't specify column names, and that becomes important. And then, perhaps more interesting, we can start looking at quality. So this quality report is quite interesting to go through. We see we have a 90% score of quality for the column shapes. What does that mean? According to the documentation, column shapes is the statistical similarity between the real and synthetic data for single columns of data. This represents the marginal distribution of each column. What is that saying? That basically means, look, how much do the values of column A in your synthetic data match up with the values of column A in your real data? Clear enough. Looks like we have a little bit of divergence, but we can look into that in a second. And then secondly is the column pair. Now the column pair is going to compare A and B, and then it's going to show maybe there's relationships between A and B. And if there's relationships between A and B, it's going to look at whether the synthetic data relationships closely match or less closely match those relationships in the real data. And so we can dive deeper because this is where it starts to get a little interesting. You can read about some of these, so we can look at the column shapes and take a look here, right? So obviously here our lowest scores are our amenities, fees, and room rate. That's where on a column by column level, it's less representative. And you can look into the scores that they use. And then even more interesting is starting to look at this pairwise comparison, because we can start to see, oh, that's a pretty low score compared with the other scores of the relationship between has rewards and amenities fee. And we're starting to also see this is a pretty low score between room type and room rate. And you can dive into more of these metrics, obviously. as you build out your own pipelines. Or you could get inspiration from SDV. If you don't want to use SDV directly, this is some ways that can inspire you to build your own or to evaluate other options. So now we're going to start plotting, and we can see this is the amenities feed. This is why it's getting such a low score for both things, probably, is we can see that the synthetic data that is producing has a very different distribution. So a probability mass over the values versus the real data, okay? And then secondly, we can look at a pairwise plot. So these are using this is one of the only times that these things actually are legible, in my opinion. But we can use these box plots to see, okay, that's maybe less helpful. But we can see, okay, for the suite versus deluxe versus basic, we definitely have some skews in our synthetic data versus our real data. Like we've inserted some significant bias. Thankfully, we kind of see like minimally, there's a little bit of consistency, as in suite, actually not quite, because deluxe definitely has some, although the real data has some weird outliers here too. And so this is starting to give us an idea, we might want to fix some of these. And so we can tinker with our Coppola synthesizer. And so here's some examples of tinkering. Now there's a few, at least, other ways that you can do these distributions, but I just wanted to show you. So one of them is choosing more of a uniform distribution, a gamma distribution, and we have the Gaussian distribution with kernel density estimator. That is a lot of words. I'm not going to get overly into it, but I have linked some examples here so you can start to dive into it and decide what really fits what I'm trying to do. Or you could literally just build something that iterates over the few and ends up choosing the best one based on the quality metrics you're trying to improve. So one or the other. So now I'm going to rerun this. Now we have our custom synthesizer that's different than our synthesizer. We're gonna now see, we can look how it did each column. So whether it did truncated norms, or, we can change this. What did I choose? One of the ones, amenities fee, quickly. So we can have a look at that, right? So we could have a look, we could gut check those, we could do it any number of ways, but we can also take a look at our scores, right? And we've improved both scores, and we can start to look at how we changed our distribution. So one of the things we changed was the room rate, and we can see that we have a very close fit. And we can look at our amenities fee, because that's another one, and we have a much closer fit than what we had before. So what I want to show here, though, is this, for example. So now we're trying to learn the distribution. In both cases, I have passed in all of the real data. So essentially, I have said, read this entire database of potentially sensitive data and make me something that makes stuff. Now, why I say probably private for these types of things is at least it's using pairwise statistical modeling. It's not doing deep learning magic, right? So we're probably going to reproduce maybe some real things from the data, but at the most, we're showing length on this like column paired with column. Now, there's ways to get fancier with SDV, and that's what I want to say is you're going to run into the question, which is, if I'm using synthetic data that ends up mirroring a lot of the raw data, why am I using synthetic data? Which was the main question that I had in the book of why are we using synthetic data? Because as a data scientist and as a machine learning engineer, then I'm just going to use the real data, and I'm going to use something like differential privacy, which I can actually reason about whether I'm recreating the raw data or not. So I just want to add this tension here. I've recommended SDV here because I think it looks pretty safe. But you probably want to put your privacy engineering hat on and think about, why are we using synthetic data? What do we need it for? Are we sending it to somebody untrusted? If so, do we want to do fully synthetic? Do we want to do more representative? What do we want to do? So just think through, do a little bit of risk analysis of why it is you're using synthetic data, especially if you're using synthetic data for privacy reasons. Okay. All right. And then we have deep learning, right? And I'm not going to show an example here because we're not going to sit around and train a deep learning model together. But there are services that offer upload your data, we use deep learning, and then we magically make synthetic data. I would be extremely wary of anybody that promises that. And I'm going to link to Damien Desfontaine's amazing talk at Usenix on why it is that we do differential privacy for these types of things, and not to just randomly train without differential privacy and then output accidentally memorized data, right? And so there's a lot of reasons to learn about how to use differential privacy. I have a video that I'll link as well. But think through, if you're going to do fine tuning, if you're going to build your own GANs, so generative adversarial networks or any other generative networks, if you're going to fine tune it, train it, or optimize it for your data, consider please using differential privacy, if indeed it is because you're worried about privacy of reproducing your actual data. And if you're just using it like somebody else's AI or LLM to produce data, just realize that it may have memorization problems, and you should probably think about that and how it might affect the types of data it generates. Also, you don't know what they trained it on, so it might have biases and other things like this. So just use with care, think about it, ask these questions, right? And if it turns out, hey, we're only using synthetic data because somebody told us it magically solves privacy, just don't believe those people anymore. It's not a real thing, unless they're telling you to use dummy data, in which they're probably not selling you a deep learning service. Okay? Okay. All right. By the way, one of my favorites that I used to recommend was Gretel.ai. They've been acquired by NVIDIA. I don't know whether NVIDIA will open source the work that they used to do, but you can check out the public archives if you're entering this. I want to generate synthetic data with differential privacy guarantees. If you have other services you've used that you trust, feel free to add them in the comments, but expect me to be wary of whatever their promises are, because that's what I'm here to do. So I hope this helped you. I'm going to link to this notebook. Maybe you get tinkering. If you have other synthetic data generators that you want to put in the comments that you like, especially if they already have paid somebody to do a third-party privacy attack and analysis on their system, which is probably what we should require of these people selling synthetic data privacy guarantees, please share them and let me know how it goes. Let me know what you're doing with synthetic data. And I hope maybe this gives you some ways to think about, oh, well, we're using this new AI code assistant. Like, what example data should I send it? Or, oh, I'm testing out this new data extraction pipeline from this new third-party vendor that I haven't ever used before. Maybe don't immediately upload a real PDF. You can use Faker actually to generate fake PDFs, which is pretty cool. So I hope this was useful, and I'll see you next week.